Welcome to another edition of the Petty Podcasts. This is your host, Stephen Petty. I've had many requests to prepare podcasts related to children and masks, so I prepared a series of 4 of these. This is the first one. These slides are going to be a bit busy and it'll be a little longer than most, but I think it's important to go through the literature and see what exactly CDC is saying. This is the latest advice from CDC. It was updated July 9th, 2021. I downloaded it on August 18th, 2021, so it's current. And under mask use, they really have a paragraph here that I'm going to take the time to read that consists of really 3 small paragraphs. The first, and they justify it with a series of references. The first statement they make is consistent and correct use of face masks reduce the spread of SARS-CoV-2, and they make a single reference to reference 78. So we're going to spend some time on today's podcast looking at that. The other 2 statements they make are most studies that have shown success in limiting transmission in schools have required that staff only or staff and students wear masks as one of the school's prevention strategies. The word one is critical, and our second podcast on children and masks will cover this paragraph and those references. And third, they say inconsistent mask use may have contributed to school-based outbreaks, and there are 2 references they cite for that. I'm here to tell you that the word may has really no scientific meaning. It's kind of like the word possible. Typically in science, we have to say probable, more likely than not, or greater than 50% chance. So let's do some reference checking. I always have spent my life as a scientist checking the references to see what they actually say. So the first statement that CDC makes supporting the use of face masks for children is that consistent and correct use of face masks reduces the spread of SARS-CoV-2, reference 78. And so I'm looking to see, does reference 78 support that statement? And it turns out reference 78 is a CDC document, so they're referencing themselves. And I've listed the full length, if you will, the reference should you choose to go look at it yourself. And what does reference 78 then say? Well, again, it's a little bit busy, but reference 78, which is the reference, the single reference they've cited to suggest that face masks reduce the spread of SARS-CoV-2, in itself is also referencing 3 other documents. So ultimately, this statement is supported, according to CDC, by these 3 references, 3, 5, and 14 in reference 78. And they make the statement that cloth masks not only effectively block most large droplets, 20 to 30 microns and larger, but they also can, they use the word can, block aerosols smaller than 10 microns. The word can is an interesting word because it doesn't say they do or they will, and so it's kind of a throwaway word. But we're going to look at the references and see what they actually say. And remember from it's a very, very small podcast, that our real interest is in the aerosols 5 microns or less. Those are the particles that reach the deep lung and also impact disease progression. They also indicate that multi-layer cloth masks both block up to 50 to 70% of these fine droplets and particles. And we'll look at those references, the only comment I have to make here is that I don't see a lot of people wearing multi-layer cloth masks, so, but nevertheless, that's how they're justifying it. And interestingly enough, they say that the filtration, I guess that's filtration of the droplets, can reduce the wearer's exposure to infectious diseases through filtration, including filtration of the droplets and particles less than 10 microns. Well, let's see what they actually say. Remember, I've talked a lot about particle sizes and gaps, and if you want to see detailed understanding of that, go see our podcast, I'm Very, Very Small, where we show that greater than 99.9% of the COVID-19 particles or aerosols are less than 5 microns and not droplets. Then we have the episode number 5, The Great Gaps, shows that masks cannot be sealed in the real world, and if you have a 3% gap area, then the effectiveness of any mask is essentially zero. And then we'll have a podcast up soon called Masks versus Respirators, which shows from the literature from 3M itself that even N95 respirators are not recommended to protect from infectious diseases. So those are some other sources of material you can go to. These get a little busy, but I want to be as accurate as I can about what these references to reference 78 actually say. So number 3 reference, what's it say? Well, as you'll see on the far right, what they've got is a mannequin set up in a cylinder. I've kind of circled that with the red box. And they measured through single coughs the various particle sizes and collections efficiencies in the plot there. And CDC, interestingly enough, is only citing the Gator 2-layer data. A couple of points to be made about this reference. The smallest size they cite is less than 0.6 microns. So we don't really know what that size is. We know that the COVID is 0.1. And traditionally in science, in the sciences, if you have delimited values, meaning they're less than, you use half the value. So we would use 0.3, which is obviously larger than 0.1. So they wouldn't have been sampling particles of that size. And CDC notes that the multi-layer mask, well, the only one here, if you look across the bottom, there's only one multi-layered mask, and that's the 2-layered Gator mask that I've highlighted with the red box. So they've cherry-picked, if you will, not in a good way necessarily, a single set of data. That is a 2-mask set of data. And the other thing is that these data span the gap somewhere between 0.3 and 7 microns. So we're above aerosol particles, and the only way that you can get to 50 to 70% data there, if you actually look at the fine data, is you have to start pulling in data that's well above factors of 20 to 70 bigger than the actual COVID particles. And the other masks were worse. So the fact that CDC uses this reference to show that masks stop COVID particles is questionable because there's nothing here to show they're measuring 0.1 micron particles. And even when they do cite a particular mask, they're citing the double layer mask, which is seldom seen worn, and they're using data way above 0.1 microns. So I wouldn't consider that supportive of their statement. The second document they cite is document 5. This one's a little easier to view and understand. Again, they use a head form seal. Remember, this is sort of an ideal seal where they, which is not reality, where they basically make sure that the mask fits well around the simulated face. And this is not quantitative work, it's qualitative work. What do I mean by that? What they're doing is they're using a photographic technique to show what happens with coughs, simulated coughs through a mask. And what they're trying to show is that the distance and the amount of material that come through the mask is less via this qualitative photography with or without a mask. Here's the problem with that. There's no definition of what these particle sizes are either with or without a mask. We don't know how many particles are there. We don't know what their size distribution is, how many of them are large, how many are small. So there's no quantitation in this study at all. And moreover, it's based on a single cough. So how does that reflect on somebody that's coughing or breathing for hours in a space? So we really don't know anything about the particle sizes, the distributions, or what happens when somebody emits more than one cough. All we know is that if you put a barrier in front of a cough, that's at least some of the larger particles may be stopped. We know that from the science. So does this really show that masks stop COVID particles? I would say not. The third study is a study, we call it number 14 because it's the 14th reference under original reference 78. And again, they use two head forms, and they're simulating breathing of particles back and forth. And what's interesting is they use simulated salt particles, which aren't biologics. They use very short distances in these studies, less than 3 feet. And there's no measurement. They use a total measurement of total particles, but there's no size distribution reported, just total droplets or aerosols. They don't even define droplets or aerosols. So we really don't know how well this study would simulate COVID particles, which are predominantly aerosols at around 0.1 microns. All we know is there's a total emissions here that is based on a perfectly sealed or ideal sealed mask using non-biologic particles of unknown sizes and distributions. Again, I don't think that you can say that supports the concept that masks stop COVID particles. So remember from earlier podcasts that droplets are greater than 5 to 10 microns in size and aerosols are less than 5 microns. And the COVID particle is somewhere between 0.09 and 0.12 or around 0.1 microns in size. So, and before I've used some work by Edwards where he showed in looking at studies from monkeys, he measured particle sizes from 10 microns down to about 0.3 and showed, and these were monkeys that were not sick with COVID and then were purposely made sick with COVID. And he looked at what the size of the particles were that were emitted with time. And the results are plotted here. They're complicated, but as you recall from these earlier podcasts, I went ahead and I took all this data that shows particle emissions from monkeys a day before they're purposely made sick and then looks up to 14 days after they're made sick to see what the emissions were in terms of total particles and particles by size. I took all that data and made it rather simple, and you can see here that for the aerosols, it starts at about 10,000 particles, and then after they get sick, it accelerates to about 20,000 particles, as you would expect. The droplets really never get off the origin. They're always less than 10 particles or so. So as we said in the earlier podcast, if I'm really, really small, 99.9% or more of the particles emitted are aerosols for a COVID-infected monkey, which is the best simulation we can for humans. And that is true before they're sick and after they're sick. And what did Edwards conclude? As you recall, he said the small respiratory droplets, i.e. the aerosols, remember this word droplets gets conflated, where the majority of particles excelled in all subjects. Well, it was the vast majority, 99.9% or greater. Recall from the Drunick work in the Holy Mask podcast that what he did was he started to put holes in masks of various sizes as a percent of the total mask area to see how it would affect the effectiveness of the mask. And what he found was that when you got to 2% hole area or gap area for the mask, that you lost 75% of whatever effectiveness it had. So what I did in this slide is I just projected those lower lines for the small particles out to see where the effectiveness would be 0. And what we found was that around 3% mask hole area whatever effectiveness the mask has, essentially zero. And remember, I also talked in that earlier podcast about the fact that if you take an actual mask like the one I wore on Spirit Airlines and you calculate the gap areas, they total to about 15.5 centimeters squared. The mask area is about 165, so when you do that math, the gap areas in the mask that I was wearing were around 9.35%. Remember, if it's over 3, the effectiveness is 0, so clearly the effectiveness for this mask would be 0 as well. I wanted also to share with you the boundaries between masks and respirators. And the big distinction that I wanted to make is, you can see on the left, you see various masks, and they basically cannot be sealed. The literature says that. The stuff on the right side of the wall, PPE, begin with an N95, then you go to a half-face respirator, and they can be sealed, at least to some extent. But I thought it would be interesting, because there is this movement to move people from masks towards N95s to see whether or not what they say. And this is the actual literature that was in a package of N95 respirators that I purchased, and this is from 3M. They make some interesting statements about the use of N95 respirators for various materials. They say they're not effective for aerosols. Asbestos, remember, asbestos is on average about 5 microns or 50 times or so greater than the size of a typical COVID particle. But more interesting, they say for biological particles, that it cannot eliminate the risk of contracting infectious diseases. So even the N95 is not recommended for larger asbestos particles, aerosols, or to stop illness or disease. So one has to ask the question, here's a respirator that can't do that, albeit on the bottom end of respirators. Certainly a mask can't do that either. Again, we appreciate you watching our podcast. As always, this one's been a little long, but it takes a while to go through the literature. We appreciate your patience. We look forward to having you view the second, third, and fourth versions of these Children and Masks podcasts. Thank you and have a wonderful day.